I expect this lesson will be significantly quicker than the last one was, and part of the reason for that is that they're really similar lessons. There's a new formula, there's some new ways of doing things, but so much of what we do is the same as it was before. So there is a formula for geometric sequences, and this is what it is. Very similar to the last one. If you want the nth term in the sequence, take the first term in the sequence and multiply by the common ratio this many times. You'll notice a lot of the elements are the same. That n minus 1 is there just like it was in arithmetic. This time it's a common ratio instead of a common difference, and this time it's multiplied instead of added because it's geometric. Remember, the idea behind geometric is that you're multiplying something each time. An example of a geometric sequence is something like 3, 6, 12, 24, 48. I'm multiplying by 2 here, right? That's an example of a geometric sequence. Okay. One of the big pivotal ideas I put down in the last video was that each time you see a value of n show up in a problem, know that you're going to need to write this formula down again. This formula here works for any value of n that you plug in. So as soon as you identify an n in the problem, you use it here and just try and solve using the formula. Most of the time you can work the problems out that way. The first example I have for us is this one. The first and fifth terms of a geometric sequence are 3 and 48 respectively. So, and some people will even sort of take the tack of writing things down as soon as you see them. This means that the first term is 3, and the fifth term is 48. And by the way, as soon as we saw that, we knew that n was 12. What am I doing? We knew that n was 5, and that we're going to be using our formula for n equals 5. It then says find two possible values of the common ratio of the sequence and use them to determine the possible values of the second term of the sequence. Okay? At this point we write down our formula. Our formula says that the nth term is supposed to be the first term times the common ratio to the n minus 1 power. We knew that n was supposed to be 5, so let's plug those things in. When I plug in 5 to this formula, I'm going to get 48, the fifth term, is equal to 3 times the common ratio to the 5 minus 1, or to the fourth power. Okay? If I divide both sides of the formula by 3, equation by 3, I'll get 16 equals r to the fourth. When I take the fourth root of both sides, I'm going to get r equals not just 2, but plus or minus 2. The problem said find the two possible values, so I found that r was plus or minus 2. Okay? Then the problem wanted us to find the possible values of the second term of the sequence. How can we find the second term? Well, we could find the second term by just taking the first term, which was 3, and multiplying by the common ratio, which is plus or minus 2. It means that the second term of your sequence will be plus or minus 6. Okay. I'm going to throw in one thing here really quickly. What if the problem had asked for you to find the seventh term of the sequence? If they had asked you to find the seventh term, I hope you recognize we would just use the formula. The formula would say that the seventh term is equal to the first term, which was 3, times the common ratio, which was plus or minus 2, to the 7 minus 1 to the sixth power. I hope we recognize that this is something that we can just do. This is what, 192? I don't have another example coming up that's like that. I'm trying to save time in this lesson. If they give you another value of n, just plug it into the formula and use the formula again. Okay? This last example that I have, the fourth and seventh terms of a geometric sequence are 24 and negative 3. Find the common ratio and the first term of the sequence. I really hope this reminds you of the last problem we did, the last example we did in the arithmetic sequences lesson. Right? Notice there are two different values of n that are given here, 4 and 7. Because of that, you should be writing down two different equations. So I want you to pause the video, write down what those two equations are, and then check back in. So the first one says that the fourth term, which is 24, should be equal to the first term, which I don't know, times the common ratio raised to the n minus 1, the 4 minus 1 power, so raised to the third power. Okay? The other one says that the seventh term, which is negative 3, should be equal to the first term times the common ratio to the 7 minus 1, or to the sixth power. I now have two equations with two unknowns and a u1 and an r, and this isn't quite as simple as us doing substitution or elimination. Sorry, that took me a while. We have to do something a little bit different, but it's still not a big deal. And really, I still see this as I'm going to do a substitution. I will solve this equation for u1. I'm going to find that u1 is equal to 24 over r cubed. If I take that and plug it in, I'll have negative 3 equals, whoops, not u1, that's what I'm substituting for, 24 over r cubed times r to the 6th. At this point, we remember how exponents work. These things will reduce down and give me 24 r cubed. If I divide 24 over, I get negative 1/8 equals r cubed. So that means r is negative 1/2, just by taking the cube root of both sides. So my common ratio is negative 1/2. What do I do with that? I can plug that back into one of my first equations. So if I take this one here, 24 equals u1 times negative 1/2 cubed. I'll have 24 equals u1 times negative 1/8. And so if I multiply negative 8 over, I'll get u1 is, let's see here, 8 times that is 160, negative 192. And that's what my first term was. Apparently my first term was negative 192. So this is a quicker video. I hope you understand that the principle behind this thing is, look, take the formula, use the formula, you win. I hope the homework assignment, that the assignment goes well for this, and I'll answer any questions if you got them.